Okay, we'll start. Good morning, everybody. Okay, welcome to this talk. This is about writing with Nickel beyond select. So I'm Prasad Varakur. I'm from the product management team, take care of Nickel. Basically, when it comes to a structured query language, like SQL and Nickel, typically all the thunder is stolen by select statement. For all right reasons, right? Okay, that is the one which helps you retrieve all the data in all possible ways. But there is much more to select when it comes to dealing with data. I think, okay, in all other talks, we have covered select indexing in much more detail. So in this talk, I will focus on what is beyond select that is provided by Nickel. Especially for an enterprise NoSQL application, which deals with a hierarchical data like JSON, the changing, transforming data is very important. In fact, often these applications require changing the structure of the data too. So that is very important. Just because data is just like us, it's living, it's changing. And Nickel very well understands this. And so it provides all sophistication and simplicity to efficiently and effectively deal with a changing and transforming data. So, application and data, the relation is like a marriage made in heaven. So the communication between the two also should be made in heaven. That's what is Nickel. Let's see what all select provides, and then I'll try to explain in detail how the commands statements work, and then show you some real-world use cases that will basically enable these applications. So you can see a list of all popular DML and DDL statements. These are all supported by Nickel. It's not just a namesake support. We have all sophistication. You can see like very complex and intricate examples that will probably simplify your application development and make it much more agile. I just want to highlight the indexing support. Nickel primarily works with all kinds of indexes, especially primary, secondary indexes, partial indexes, covering indexes. I think I'm assuming, okay, you know all this stuff, which are primarily useful for select, but most of these DML statements, they take a where clause where you can provide a complex filter to work with a subset of data. So in all those cases, the indexes will be useful, right? That's where, okay, indexes play with all the DML statements too. So what's the advantage, right? So without a great language, declarative, powerful language like Nickel, application has to develop all the logic to deal with whatever you want to do with the data. And that's not very agile, and it's very expensive because of obvious reasons. And Nickel basically combines and takes the responsibility of all this application logic and puts it into a core engine itself so that it is much more efficient, much more stable. You don't have to worry about the best ways of dealing with data. A declarative language is something like you just tell it what to do, and it figures out how to do it the best possible way. So the first one, let's see, we need to ingest data. That's the first step in any data lifecycle. So insert, most of these statements will follow the similar format. I'll show you a syntax diagram and try to explain it briefly. You can look at the documentation for more details. But I want to highlight insert statement, right? For example, it works, the key space is basically a bucket in Couchbase for now. And it works with two subclauses, the insert clause as well as the select clause. So data you want to insert that can be explicitly specified as key value pairs, or you can issue a complex select query on some other bucket or some other data set, or it can be completely a subquery, which is producing a transient result set, and then, okay, insert it into another bucket. And then you have a returning clause where you can return back all the documents that are actually inserted. In case of some documents are not inserted for whatever reason, you can validate them, or you can post-process them without a subsequent following up select. By the way, the returning clause is optional. So the insert values clause, it has a keyword values, and then any complex expression can be given for key and value. So just see the power of it. It's It looks very simple in the syntax diagram like this, but expression is very powerful. You can write very complex expression using functions and various language constructs that NQL supports. I'll show you an example. Let's look at our great scientists. Okay. You can just use insert into scientist values. The first one is the key. I just hard-coded the key here with the first letters of first name or last name. But that can be a big function in itself. And then like a value. If you want to insert multiple values, you just do the same thing, followed by commas. So let's see, okay, how this thing really works. Actually, we provide another statement called explain. If you run that explain, it will show in every detail that what exactly NQL does inside, right? It shows the query plan, basically. But at a high level, when query service gets an insert statement, it basically extracts the data, and then it sends it to the data service to store the data. But in the back end, so independently, the data service syncs up the data. If there are any indexes created on the bucket, the indexes will be synchronized. Let's look at insert select. This is like, okay, much more fancier. So you provide the key and value, and probably you want to extract all the papers by a certain scientist, and then all the database scientists, for example, and you want to insert them into a different bucket. So you can issue a simple select query. That can be much more complex select query too. I just use the upper function there to generate the key, but that can be another generic function too, to generate the key as well as generate the value. And look at another powerful thing there, right? Okay, you can just create the objects dynamically here. You just, okay, write a JSON object there, the key and value parts, the name and papers, they are also dynamically, you can use any functions to generate those. So this looks very simple, but okay, it's very powerful here. I think there is a typo here, the country equal to US. I think I changed the example to use all the database scientists. When it comes to select typically works with index for all the best performance. So that's where the query service first connects to the index service to retrieve all the qualifying document IDs, right, that match the select criteria. And then actually insert corresponding documents, all the new values into the data service. So you can see a few additional steps, but that's the best that can be done. And just to highlight here, I won't get into too many details here. You might have heard this in the NQL workshop and in other sessions. So whenever you're reading data from index, you can specify scan consistency. So that basically kind of equivalent to the standard relational databases isolation levels you're probably familiar with. But whenever somebody is reading data and your data is probably not up to date, so you want to tell per query how consistent you want to be, right? Okay, it's a clear trade-off between performance and the consistency of the data you want. So not bounded means, yeah, whatever is the data available in the index, get me that. A request plus means whatever is my request has made changes, right? Give me the latest data up to my request. That's what it says. And at plus, generally, you can provide any timestamp and then get a latest data up to that point. I think, did I miss something? Okay. Okay, let's look at the delete statement. A delete statement helps you delete unnecessary data or purge unnecessary data from your buckets. But this is also special because it understands return clause, limit clause, and where clause. So if you know the use keys, right? If you know the key of a document, you can always specify a key and quickly remove a particular document. But you can specify any complicated predicate to the where clause to select a subset of documents to delete. And also you can use limit clause, for example, if 1,000 documents are selected by your filter and you want to delete only 100 of them, you can specify that. Okay, so I don't want to delete any real scientist names, so I used a foobar here. So we want to keep and respect all our great scientists. And see, okay, one more thing I want to highlight here, using of the user index. So if you create a specific index, then when you're using a where clause, you can specify the user index clause so that that can be used for the delete command. And be careful with this. If you don't specify anything, it might remove everything in your bucket. It might just empty it. So And the diagram looks pretty similar to insert. But I want to highlight one thing here, that is the CAS production. Okay, what is that? It's like compare and swap. So there are two stages happening here. In step 3 and 4, you're getting a list of documents that will be deleted because all those documents are satisfying your search criteria, whatever their predicate is. But by the time you go to the data service to actually delete the statement or the document, in fact, the criteria might change. You're looking for probably status equal to 1, but by the time you go to the data service, status is already 2. So you want to make sure whatever you selected from index, they are consistent. So Nickel internally uses the CAS, which is pretty much like a mutex or a lock in some sense. So it gets all the documents which qualify and then make sure their state doesn't change when you're deleting the actual document. So I'm kind of using loose words so that you get the concept here, right? If you have any questions, you want to dig deeper, we can always chat later. And feel free to ask any questions, stop me in the middle. And then the next popular one is update. In fact, it is much more intricate too. It has more clauses, so you want to update any data. So updating comes in basically two flavors. You are creating new data fields, or you are updating existing fields, or you're probably removing some attributes or fields in your document. So that's where the set clause and unset clause, those two come into picture. And they are themselves pretty intricate, and let's see how that works. They are the new additions here. So I'm not covering what I covered before. So set, for example, it takes a bunch of values. It's like a path, and then the new value. And then for each of those fields that you're setting, you can specify an update for clause, which is basically, if you're dealing with the array, for example, you can navigate through individual elements of the array, and then you can specifically select which elements you want to change. And these for loops can be nested. So that's very, very powerful, actually, right? If you see that, if you have a document with 3-4 levels of nesting, and you want to change something in the third level of nesting, you can beautifully write a simple code. Just imagine writing application code to deal with all that logic. And if you don't like something in this, okay, you can always change your query and then enhance it. That's where agility comes from Nickel. And similarly, unset basically removes a particular field. It's very similar in structure. And the looping you see here basically is so that if you want to update multiple fields in a single shot, you can do that. So update for expands into this one, right? Okay, you can see the for loop iterates. You can have probably multiple, like it's like for loop with ijk, 3 variables you want to iterate through a multi-dimensional array. You can do all of that. And the when clause, which is part of the for, that helps you qualify specific elements in the array. Let's look at a quick example. So if you want to update the scientist's documents and add one more paper to Professor Sumit Ganguly, who happens to be my advisor. So you can just use any function, array append, for example. Papers is an array of papers they have published. So you just want to append one more paper to them, right? And then beautifully it just works. And for example, this unsetting, for example, right? The great Alan Turing, okay, probably he doesn't need an email, right? If you want to unset that value, you can just simply unset that. Okay, so here, let's look at the picture. It is very similar to the delete what we have seen. And I think, okay, in theory, the flow of information and control information, everything is exactly the same. So do I want to highlight anything here? Not really. Okay, let's look at merge, right? Which is probably not as often used, but it is very, very powerful statement. And sometimes, okay, it is not used because of its complexity. I'll try to kind of simplify it at probably like 10,000 feet. Let's look at that. So merge basically, it's working with 2 sets of documents, or per se called, let's use buckets for simplicity. So you have a set of buckets, which probably is assume it as a main river of data. And you have small streams coming and joining to that. So how do you join them or merge them, all these smaller streams of data into the main river? That's the problem merge is trying to solve. And when you are merging, you want to probably take different actions based on, okay, how you want to join. For example, I think I have an example there. Let's go to the example. But looking at the railroad diagram here, so merge into the key space ref. The first ref is the destination, that's the river. Using merge source, that's a small stream. So you have smaller streams of data that is getting merged into a bigger stream of data. So this is the destination, and merge source is the source of data. So when you have two things, always they should be related. Okay, you need to find a way to kind of join these two. So pretty much it's like a join on a foreign key, primary key, if you're coming from the relational world. So you want to tell how you want, if you pick one document from the river, one document from the stream, how do you want to identify and relate these two? So that's what is the key clause. Okay, that tells, okay, yeah, use this key clause, probably this is A in the stream, B in the river, but they are actually the same thing. Okay, you want to equate them. And if you match, or if you don't match, there are the only two possibilities, right? And you want to take certain actions. The action could be insert, delete, or update. They are the core operations we can do. Okay, so merge source, for example, that doesn't have to be just a bucket. You can use a whole select statement again there as a subquery, which is so powerful. I'll show you in a real world use case where that can be a beautiful trick to solve some tricky problems. And look at the merge actions. The update, delete, and insert. All three are optional, which means you can do all three whenever a document matches or not matches. And this is like a little more expansion on the actions themselves. But this is like a subset of the full-fledged corresponding actions. So you cannot use a full-fledged insert, delete, and update here. But it's a limited version of this action for that one document. Because you're going through each document at a time and then evaluating what you want to do with that document. So this is restricted to act on that particular document. For example, when you're not matching something, that's when you want to probably insert, right? If you don't match something, update and delete doesn't make sense. Similarly, when you match something, then insert doesn't make sense there, right? So not matched is linked with insert, and matched is linked with update and delete here. Similarly, upsert is kind of redundancy. Right? Upsert is update plus insert, which is already taken care of. So upsert explicitly is not supported here. I hope this will clarify some of the confusion, if at all there is something. So let's look at, do I have an example? So this is the example. Basically, I have a bunch of cars with some mileages, which is the river, and the car changes is like, okay, whenever you have some oil changes or something like that, okay, you're accumulating all the mileage information. So you want to frequently or probably often, right, okay, you want to merge these two documents. That's the example, context. So you have these two documents. When they come into the merge statement in the nickel engine, you will try to do a join on the car ID here. If you see here, the car ID of the car changes, 1, 2, 4, they correspond to the keys of the actual document. That's where the foreign key, primary key linkage comes. And if you match, you do update and delete. If you don't match, you can do insert. And for each document, this is iterated, and then the results are output. Okay, then the next command is a prepare statement. So prepare statement is like preparing everything a priori so that you can do your best in performance. So if you have certain queries, which is normal for any enterprise application that are very frequently run, right, that are run in production and all that. So you want to optimize those queries. So once you have an optimal query, so you want to prepare that so that all the query planning phase is already taken care of. So the encoded plan is written back when you prepare a statement, or you can actually give a user understandable name so that the query plan is cached in the query engine. So next time onwards, whenever you run the query, you either provide the whole plan, the encoded plan, or just give a name like find cars, and then the query is immediately run. That will basically cut few phases in the query processing stages.
This plan, and I mean, can you import the plan? Suppose if you have certain plans, correct, and it's now got obsolete, but you have somewhere you have stored those plans. Can you import those plans there? Can you follow?
Sure. So we have a internal bucket or a table kind of a thing, right? It's a system bucket which caches all the prepared statements. So you can run a select on that, and then you can get all the prepared statements. Or when you actually run the prepared statement, it returns the plan. You can just cache it wherever you want. And there is a subsequent execute statement to which you can provide the plan, and then the query service will just respect that, and it will follow through the plan. Okay, this is an example. For now, the execute part, right, that can be run through curl, which is the REST API, or through CBQ, which basically says through the web console you cannot run it. Right now we cannot pass parameters, for example. There's a limitation right now, probably it will be soon removed. But you can use the other tools like CPQ and curl to run these prepared statements. Infer is a new statement we introduced in 4.5, which will basically help you infer is for inference, discover the schema of all the documents in your bucket, right? So clearly we have different flavors of documents, different versions of documents in your bucket. So you want to find out what is the structure looks like. It's very useful for development as well as for administration. You want to figure out what is there. Even you want to write a query, you want to make sure, for example, how much percentage of my documents have a specific field. If you know that, you can probably develop accordingly. Or probably you may want to cleanse data, because just having completely random data is also not good for the application. You want to use everything in moderation. So Infer helps you with that. It is actually baked into the web console. You can, when you on the left panel, I think, later I have a picture probably to show you that. It basically shows you a bunch of information about all the documents on a bucket. If you just hover around the bucket name, it will show you all the details. So if you want to run it from a web console or a CBQ, right? It basically takes 4 parameters, and it's based on sampling. If you want perfect information, you can use 100% sampling size. So sample size, default is like 1,000 documents, but you can select whatever you want. And the number of sample values. So whenever we sample, we cache some values so that we can show you the glimpse of what the data looks like for each of the fields. So by default, it is 5, but you can change how many samples. Sample is basically like example here. Don't confuse between the sampling of sample and the sample as example. And then the similarity metric, that sort of defines a flavor for these documents, right? Probably if you have 80% of all the fields between 2 documents matching, exactly same, but maybe 20-25% different, then you may want to consider them as same flavor, right? So that percentage you can set. So by default, it is like 60%, but you can change the percentage. And then dictionary threshold is something tricky, so I try to kind of give an example here. So when you, in certain cases, it's not a best practice, but it's enterprise world, everything happens there with exceptions. So you might probably have a bunch of values or sub-objects whose keys are different. For example, it's a key in some other bucket probably. So if you have ratings, user ID is your key, and some value for that, some sub-object for that. So this structure of this is very different for each document. I might have user 1, 2, 3 here and XYZ somewhere else. So it's very difficult to figure out what is the structure of that. But we know there is a structure here because all of them are actually representing a ratings data, right? The schema is exactly the same. So this field tries to kind of clarify, get some guidance from the user on that. So it tells basically if the sub-object structure is exactly the same, should I consider all of these higher level objects as same thing? This is called a dictionary pattern in the design patterns. So you can specify at what stage basically, it's a threshold basically, right? After which it should consider them as same. Here is an example, for example. So that will figure out as per your specs. And right now, the Workbench uses this just to kind of highlight some use cases. And typically all the BI visualization tools, they need to figure out, because in Tableau or probably in Cloud9 charts or Slam Data, right? All these beautiful visualization tools, you're dragging and dropping off your dimensions and metrics and all of that, right? But to figure out what is what, you need to understand the schema. For example, Cloud9 charts guys already use Infer, but if they don't use, like for example, the Simba drivers, you might have heard the talk yesterday, they have implemented prior to 4.5 their own sampling mechanisms to kind of figure out the schema. But now we support more natively. So these tools will be soon use these features. Explain, actually, I put it at the last, I don't know why, but this is the most useful thing in query processing for everybody, and not only developers, everybody needs this. It tells exactly that before you finalize your statement and move it to production, you really want to look at the explain plan and make sure it is doing what you intend to do. If there is any small thing, okay, it can make a big difference in performance and probably resource usage. A lot of things come into picture. It exactly tells what Nickel will do. Because of lack of space, I just put a simple insert statement here, which is by value, which takes the value and sends it to the data service. But try to do it on any complex select statement, that will be much more multiple pages. But it's worth it. Everybody should be familiar with using explain. And whatever the query you have, just prepend it with explain. That will show what Nickel will do with it. Right. If you want to see more stuff, okay, we can probably see me at Nickel booth or any of our team at Nickel booth, and we can show you more stuff there. Let's look at some real-world use cases. All this stuff looks very fancy and very useful. And in fact, okay, world has been using them in the SQL world for years and decades. But let's see, okay, in the NoSQL world, how people are using them. Some of the simple use cases, I kind of obscured the content so that, okay, it's not exact replica of the user case. So delete, this is a user profiles use case where you want to delete some stale users. Any big application ends up a lot of users, and you don't want to kind of give all your great resources to every user, right? Probably you want to tire them. Give all your best resources to the active users, but stale users, you may want to either delete them or move them to some other tier. So delete with a where clause. If it is changed, you probably have a history log of them. So you have some criteria here to figure out this guy is not active. So then, okay, you may want to delete them probably. So it's very useful, and be careful here. Just I want to highlight, small typo can cause a problem. If you use a field name without quotes, that is actual field in the document, then it looks for the field name and then, okay, deletes it in the where clause. You put it in a quotes, right? Then that becomes a value and evaluates to true, which means the where condition is true. That means it deletes everything. Every document satisfies the where condition. It can be a simple typo, but that can cause a big trouble. Let's see insert. Insert, especially with select, that can be like do wonders. Actually, Keshav has written a great blog, and DZone, please check that. It shows, looking at this data available, provided by data.gov, right? Okay, you have all kinds of data available there in CSV format, in JSON format, and all of that. In literally minutes, a couple of minutes actually, you can import all of the data into Couchbase and Nickel, and use Nickel queries to actually get a lot of insights from the data. If you look at the document, actually, right, structure, it is much more complex. In a weird format, actually, they put all the documents into an array with each element being an actual document, right? So they have a meta section in the front where you specify the structure of it, basically. It's like specifying the schema of the document array elements, right? And then, okay, they have a big array of data that follows. Basically, every element is an actual document, right? So I have seen, actually, for example, if you look at NASA.gov, right, NASA documents, it's like 93 MB, one document, right? It is difficult to deal with them, right? Okay, how do you import that into Couchbase? Or even just running any query on one document with so many arrays, it becomes very complex. So you want to fetch all these data elements and actually make them into an independent document. So this logic here helps you with that. In fact, the blog explains it much more clearly. I'll try to quickly skim through this, right? So you're basically looking at the subquery part of it. You're looking at the metadata, actually grabbing all the field names, which are these. And then actually data is the array. And you call all of this result, which is basically the field names and the data array, alias it to D. And now you unnest. Unnest basically is an operation that takes an array and actually unnests each element into a document of itself. So d.temp, that is the actual field name in your whatever original document is, right? Which is each element of the array. That is the actual document. They have somehow compressed it into one document, but we are doing the unnesting part of that. And then now here, this object logic, look at this power here, right? Okay, you are dynamically creating an object here with, you're getting the index in the metadata part, right, for each of the fields, and that you're making it as a key in your actual final document, right? And the value is the corresponding element in the data array. It's simple math, actually, but the point is the language has the constructs to express that in just one line. Look at the power of the language. And even just write a small program in any language, this will take from 20 or 30 lines, and okay, then probably you have to massage it much more. Right? So update is another thing. For example, one of our customers, in fact, even for the demo, probably you would see today evening, I was actually our Cloud9 and Slam Data there demoing how easily analytics can be done on Couchbase data. So whenever you are trying to import data, dealing with data with timestamps, it's not easy. Timestamps always, right? Okay, you need to probably massage them a little bit so that the time zones are proper and the date formats are proper, aligned with whatever the application wants. So this update statement simply does that sanitizing data. It's very easy. In one line, probably you're basically picking whatever the date format is. For example, some departure times, arrival times. You pick the data, it's just a string value. You're picking up exactly whatever components you want and then concatenating them to create a new value for that. So this is your simplest form of ETL done probably with one nickel statement. Okay, this is another beautiful, powerful thing. Okay, I just love this. You should see some forum discussions on this topic. Actually, I just picked it from there. Customer basically says, okay, I have a 4-level nested structure. I want to update something in the 4th level of nesting. How do I do that in an efficient way? So you can say update and then write for loops, 4 for loops in the set clause of it. So array flatten is a typical array flatten function as it is available in Java or any other programming languages. It just flattens the array to whatever the level you want. So this is the 4th level. So you can see there is a nesting of array here. Array flatten takes the array, which is again array flattening of the next inner level, right? The 3 levels and 4th level is what you want to update, right? That's what you want to update. So the value you are updating here, and then 3rd, 2nd, and 1st level you are incrementally looping through. And you can have a when clause. For example, whenever the 4th level ID is matching this value, then I want to set the value of attribute to this. So this shows your data structure here. Upsert is another thing. Okay, I didn't get a chance to talk about it much here, so I have a quick example here. It helps you with basically, if you want to insert the data, insert with update capability. That's what upsert is. So if you already have a data, you want to update it. But if you don't have the data, you want to insert it. So it's kind of handy to some extent, right? But it is very useful in some cases, in some tricky cases, basically. So this is like you have a summary of all the data. You are probably maintaining summary of the data, all bunch of documents. Create a summary here, and then, okay, you already have a summary, one document. Probably every week or maybe every month, you want to re-summarize data and probably update whatever you have. So you don't want to figure out, okay, whether your summary exists or not for your various documents or various departments or whatever is your organization. Just run upsert so that, okay, it summarizes the data, and okay, if the data is already there, it just updates it. Otherwise, it just creates a new data, right? This is very often used in probably in, again, analytics use case. But in general, okay, upsert is very useful. Merge. So I think I have only one example here. In fact, I want to show you some different example here with source being empty. So this is a little special because what the customer wanted is, okay, he want to insert a document based on a specific key. He has a specific key, he want to insert the document if it doesn't exist. But if it exists, he want to update a specific field in the document. So upsert could have done the job if it is just replacing the whole document, right? But now, how do you do the trick? So merge comes for rescue here. So where your river, again, is product, but your stream is nothing. Basically, it's empty. You're just tricking it, basically. You're using the power of this language expression here to kind of, okay, do the job here. But you're trying to join on a key because the document doesn't exist on the source. You just provide the key. You know the key of which document you want to merge. So it joins and, okay, provides the value. Then if it matches, then you say, okay, update whatever the counter you have, increment it. If it doesn't match, then insert the whole document. Okay, this is the web console. Sure, I'm almost done. Yeah, a few more slides. This is showing, okay, how the infer output looks. I guess you can see it here. Right? If you go to web console, this is the default view. Actually, you can see on the left pane, I just expanded it a little bit, widened it. The list of buckets are shown here. And you basically hover on it or expand the drop-down menu, then it will show all the flavors of the documents that particular bucket has. And it shows if you hover on any of these, it will show you the samples I mentioned, right? The 5 examples it will show. And it also tells what percentage of documents have that particular field in it. So this is an easy way to kind of get a feel of how your data looks like. And if you want more accuracy, less accuracy, you can always change it. But by default values are tuned to kind of give you a quick idea of what your bucket looks like. And if you run the command, then you can get all possible views, very detailed information on the right pane here. You can see it as a table or a tree or a JSON, like any other query result. This is one thing I wanted to show you. It's something to do with select as well, but it comes from the stock trading world. This is great to see that financial world and with all their complex equations, they are using nickel and they are really loving nickel. So just to show an insert select example here, right? Tax lots is, I am not really good at this financial concepts, right? But whatever I understand so far. The tax lots is a concept very well explained in this blog by our SEs. And they have, in fact, detailed analysis of, how nickel could address that problem. Just look at the query. I'm not getting into details here. They are trying to insert into a temporary table, which is typically available in other databases. You can create a temporary bucket kind of a thing based on a complex criteria. It's basically using some sale value and how many units are sold and how many are bought and doing some math based on that to optimize their profits. That's what it is trying to do. You create all of this, select all of the documents and create into a temporary table, but the kick is here. They want to use a almost like 4 or 5 level of nested selects with bunch of aggregations, because aggregations are happening on last probably few quarters of your stock trading. You summarize the values and then join them with the temp table you created before and finally get some interesting numbers they want. That is needed to make a decision right now. This is just to show you, just feel the power of nickel and use it. I think that's it, my presentation. Thanks for being here. And any questions? Okay, thank you.